For as long as we've known, a serious spinal cord injury has been one of the most frightening diagnoses a person can get. But what if the secret to fixing it was hidden inside the body's own original instruction manual? What if we could use that to write a whole new chapter? Well, today we're looking at a breakthrough that might just do that.
Right, let's just get straight into it. For a very long time, the thinking in medicine was pretty clear. If you sever the connection between the brain and the body and the spinal cord, that's it. It's permanent. This wasn't just seen as a tough problem to solve. It was basically considered a law of biology, a final, irreversible loss of movement and feeling.
So to really understand why this new research is such a game changer, we first have to appreciate the huge biological wall that scientists have been banging their heads against for so long.
Okay, check out this contrast because it's at the heart of the whole problem. If you break a bone or get a deep cut, your body kicks off this amazing repair process. But the central nervous system, we're talking the brain and spinal cord, it just doesn't. It's always had this incredibly limited, almost zero ability to fix itself. And that is the fundamental challenge.
But it's against that backdrop of impossible that one scientist asked a really simple but totally revolutionary question that kind of changed everything. And this is her, Professor Tatiana Sampaio. For nearly 30 years, think about that, 30 years, her work has been this incredible story of scientific grit, just focusing on one single, ridiculously complex problem and refusing to believe it couldn't be solved.
And here it is. This is the question that drove all that research. It's so beautiful in its logic, right? She looked back at how our bodies are first built, way back in the embryonic stage, and she thought, hey, if this one protein is the architect that builds our nervous system from scratch, could we maybe bring it back to the construction site to guide the repairs after an accident?
So that question led to this amazing innovation, something her team calls a biological scaffold. Let's get into how this thing actually works.
So the star of the show is this protein called laminin. When we're just tiny embryos, this molecule is like the project manager. It tells the brand new nerve cells where they need to go, helping them form all those super complex connections that become our nervous system.
Okay, so here's the big leap that Professor Sampaio's team made. They figured out a way to link these individual laminin molecules together, almost like Lego bricks, to create this three-dimensional mesh. So it's not just laminin anymore, it's polylaminin. And this is the biological scaffold they designed to place right at the scene of the injury.
And this is probably the best way to think about what polylaminin does. It's like a biological glue or a trellis for plants. It doesn't actually replace the damaged nerve cells. What it does is create this perfect supportive environment, almost like hitting rewind and recreating the conditions of the embryo that gives the existing nerves a fighting chance to survive and start growing again. And it's a real multitasker. It does 4 really critical things. First, it helps the neurons survive that initial shock. Then, it calms down all the inflammation that can make things worse. And this is the big one. It provides a physical path to guide the new nerve fibers as they try to grow across the gap. And hopefully, that helps them reconnect the broken circuits.
The science is just fascinating, but the part that will really give you goosebumps is what started to happen when they tried this out in some early human studies. And there it is, this is the headline. In these early trials, patients with what was considered complete, irreversible paralysis, they started to get some voluntary movements back. Functions everyone thought were gone for good just started to return.
And that is why this is such a massive deal. These results aren't just a tiny improvement on an old treatment. They are a direct challenge to a medical belief that's been around for over a century. They're suggesting that the central nervous system can heal itself if you just give it the right tools. So what's next? How do you take a discovery this huge and turn it from a few amazing stories into a real, validated therapy that people can actually get?
Well, this timeline really puts the hard work into perspective. This didn't happen overnight. It started with basic research back in the 90s, then years of work in animal models, then those first incredible results in humans. And all of that has led to this moment, the official green light for a phase 1 clinical trial, a huge milestone that's set to kick off in January 2026.
So this first formal trial is going to be small and very focused. They'll select 5 patients who have very recent and complete injuries. The polylaminin gets applied right at the injury site during surgery, and then those patients will be monitored like you wouldn't believe. And the number one goal here, the primary objective, isn't even about measuring recovery. It's all about proving one thing, that this therapy is safe.
And we have to be super clear about this. As exciting as all of this is, polylaminin is still experimental. The road to becoming a standard treatment you can get at a hospital is long. Its final success is going to depend entirely on the results of this safety trial and then the bigger trials that have to come after it.
But whatever the final outcome is, this research has already changed the game. It's already kicked off a whole new era of hope. And here's an amazing part of the story. This is a 100% Brazilian technology. It was invented and developed from scratch inside a public university, which is just a monumental achievement for the scientific community there.
So, if you're going to take just one thing away from all of this, let it be this huge shift in thinking. The goal here isn't to replace what's broken with stem cells or some kind of computer chip. The revolutionary idea is to just create the right conditions and then trust the body's own amazing ability to heal itself. It's a fundamental shift from replacement to regeneration.
Which really leaves us with this one powerful question. Thanks to 3 decades of dedication and one beautifully simple idea, we can actually seriously ask if a devastating injury, one we used to see as a life sentence, could one day become treatable. And for thousands of people and their families around the world, just being able to ask that question, well, that's a revolution all by itself.